Very good morning, all of you. I am Ravi Kumar, your new chemistry lecturer. So, today we are going to start one new chapter, that is structure of atom. What is that? Structure of atom. Already you know what is that atom. So, different scientists are trying to give that different structures of the atom. So in the early 19th century, so first Dalton has given few important postulates regarding the atom. So actually atomio, so this atom is come from Greek word, that is atomio. So atomio in the sense that is uncuttable. Atomio in the sense that is uncuttable. So to explain the structure of the atom, different scientists try to use the different kinds of atomic models. So in that we will discuss few atomic models. So mainly what we will discuss in this chapter. So mainly we will discuss the different atomic models. Next, what are the fundamental particles? What is the wave theory? And what are the electromagnetic radiation? What is the wavelength? What is the frequency? And different kinds of terms. And next we will see that de Broglie's wavelength and Schrodinger equation, electromagnetic, then quantum numbers, and next another one, rules for the filling electrons. So these kind of things we will discuss in the structure of atom. So first we will see the Dalton's atomic theory. So Dalton's atomic theory. So what Dalton's atomic theory is? So according to the Dalton's atomic theory, the matter which is made up of small or tiny indivisible particles, they are called atoms. So matter is made up of small indivisible particles, they are called atoms. And next another one, he said that compounds. So compounds are made up of two or more atoms, they are combined in a whole number. The weights of the atoms combined in a whole number. And one more thing, the element which contains the atoms which are identical, and different elements contains different number of different types of atoms. So their properties are different. So element containing atoms are having the same physical and chemical properties, and one element to another element. What is it? One element to another element, different atoms are there. The properties are also different. So Dalton explained that law of conservation of mass, law of definite or constant proportions, next law of multiple proportions. So he explained all these things. So and he said one more thing. What is that? The atom is indivisible. So he said that atom is only one, that we cannot cut into further. Is it clear? And one more thing, if you take that ebonite stone, anything, if you rub with the zinc or wool, we will create the electric charge. So how it is possible? So these kind of things are not explained by the Dalton. So this is the few important things from the Dalton. Next, another one, fundamental particles. Fundamental particles. So generally you know that electron, proton, neutron, these are called fundamental particles. Along with this electron, proton, neutron, we have the positron, neutrino, and different kinds of subatomic particles, but they are very they are having a very less time. So within fraction of second they can disappear. So that does not exist permanently. So electron, proton, neutron are the main subatomic particles. Even if we have the remaining, that we cannot consider. So first one, that discovery of electron. Discovery of electron. So who discovered the electron first? So electron was discovered by J.J. Thomson. So what is that J.J. Thomson? What he did to explain the existence of electron in the atom. So he has taken a discharge tube experiment. Discharge tube experiment. This discharge tube is given by the actual Crook. First constructed by the Crook, the scientist Crook. So how we can explain the existence of electron? By using the discharge tube. So discharge tube is a glass tube. Discharge tube is a glass tube which contains metallic electrodes that are connected to a high voltage battery. So this is a pump. Here by using this one we can adjust the pressure. So this is a connected to the negative terminal. This is connected to the positive terminal. Is it here? So now, so in this we are having the gas which is present at very low pressures. Gas at very low pressure. So the low pressure that is nearly 0.1 mm of Hg. So here is a high voltage. So nearly we will take here 10,000 watts. So here the voltage will take nearly 10,000 watts. So by this experiment, J.J. Thomson, tried to prove that existence of electron in the atom. So how he did that? So when applying that high voltage electricity in the discharge tube, so he observed that actually we cannot see that rays, but we can observe that. He observed that some of the particles are moving from left side to which is connected to the negative. So he said this is the cathode. So this is the anode. So the particles are moving towards cathode to anode. Is it clear? And one more thing, he observed that when we keep one pinwheel, so what is the pinwheel? Like this small pinwheel we get that in the path of the cathode rays. What we get is the cathode rays. So cathode rays. So what is happening there? Slowly they are moving the pinwheel from here to here to here. So they are having the kinetic energy. We said that cathode rays are having the kinetic energy. Is it clear? They are having the kinetic energy. When they are going from cathode to anode, if you keep any electric field, the cathode rays deflected towards positive plate. So by observing this one, when electric field is applied, that cathode rays are deflected towards positive plates. So there are some negative part is present. So that's why electron is negative in nature. Then Stoney said that. He said that there is a Stoney. That is a Stoney scientist. He said that there is a electron. He said that there is a electron. So and what are the properties? So it is having the kinetic energy and it moves in a straight line. It moves in a straight line, and it can exhibit the fluorescence and phosphorescence. It exhibits the fluorescence and phosphorescence. Is it clear? So, and if you keep the magnetic field, right here, now if you keep the magnetic field, that cathode rays deflected towards south pole. Deflected towards south pole. In the electric field, that is deflected towards positive plate. In the magnetic field, cathode rays deflected towards south pole. And the charge to mass ratio. So we discuss this one first. Charge to mass ratio is constant for any gas you take in discharge tube. Any gas you take, the charge to mass ratio is constant, which are taken in the discharge tube. That's why electrons are said to be constituent particles. When cathode rays strikes the metals, heavy metals, produces X-rays. When cathode rays strikes the metals, it produces the X-rays, and when it touches the heavy metals, it produces the incandescence. So this is about the discovery of electron. So this was given by the J.J. Thomson by using the discharge tube experiment. This discharge tube created by, discovered by Crook. So in the discharge tube we contain two metals which are closed or sealed in a glass tube. So they are connected with the high voltage battery. One is positive and one is negative and one is a positive. So while you cannot observe that, but the properties you can see that. What kind of properties? If you keep any shadow here in the path, if you keep any opaque material, so it casts its shadow on anode. Is it clear? And if you keep any pinwheel, this is the opaque material, cast shadow. Is it clear? So pinwheel we keep here that slowly moves towards anode. So that indicates it has a kinetic energy. If you keep any electric field that deflected towards positive plate, means that rays are negative in nature. That's what they are considered as negative particles. That electron name was given by the Stone, E.J. Stone, and they are traveling in a straight line, and it can exhibit the fluorescence and phosphorescence. This you can see in the picture tube. In the TVs we are having the, we are getting that picture tubes. That picture that is mainly depends upon the fluorescence and phosphorescence. So in the magnetic field, cathode rays are reflected towards south pole, and very important, charge to mass ratio. The charge to mass ratio is constant for any gas if they have discharge tube. So electrons are cathode rays is known as constituent particles. When cathode rays strikes the heavy metals, produces the X-rays. Produces the X-rays. So these are the important properties of cathode rays. Now we will see that discovery of proton. So before that I told you the charge by mass ratio. We will see that charge by mass ratio. So what is the charge by mass ratio? The name saying that charge to mass ratio. So charge to mass ratio. Charge to mass ratio. This is also given by J.J. Thomson by doing the one experiment that you get here. This is a cathode. This is the anode. And here observe carefully. I am keeping here U tube. So in the sense, suppose if you take this is a discharge tube, I am keeping one U black tube. This is actually magnet. So I am keeping like this. Is it here? So this is one magnet. Just I am keeping like this. Is it here? So I am giving electric field. I am giving the electric field also. I am giving the electric field, one is the positive and one is the negative. When this is connected to a battery, when it is connected to a battery, so you can see this kind of. So when it starts to this screen, what we are adjusting here, it will give a flash. That's called fluorescence. This is a A, this is a B, this is a C. Is it clear? Is it clear? When cathode rays, that rays, there is a magnitude depends upon the magnitude depends upon the magnitude of the cathode rays, give the more best result. And one more thing, the fields what we are saying, and one is electric field and one is magnetic field, and one more thing, particles mass of the cathode rays, which is a lighter that reflected light. Suppose in that electric field, in the electric field is actually what is that? It will move towards electric field. So this is a negative, move different towards A. Is it clear? In the magnetic field, in the magnetic field, it will deflect towards the south pole. Sorry. So in the absence of both fields, or if you balance the both electric field and magnetic field, that reaches to the point B. See here. C in the presence of magnetic field, A in the presence of electric field, B in the absence of R. If you balance the both electric field and magnetic field, so by the magnitude of the cathode rays or mass of the particles, by adjusting them, we can calculate the charge to mass ratio. That is, charge to mass ratio is 1.7 into 10 to the power of 11 coulomb per kilogram. So what he has given that 1.7 into 10 to the power of 11 coulomb per kilogram. So this is the charge to mass ratio of electrons or cathodes. Then come to the mass of electron. So what is the mass of the electron? So mass of the electron was given by the milliton. So that is a milliton. The experiment is milliton ion drop experiment. So what is the milliton ion drop experiment? What it says? So milliton ion drop experiment gives that information about the mass of electron is equal to 9.109 into 10 to the power of minus 31 kilograms. So mass of the electron is equal to 9.109 or 9.11 into 10 to the power of minus 31 kilogram. Now charge of the electron. So what is that charge by mass ratio? Charge by mass ratio is equal to 1.7 into 10 to the power of 11 coulomb per kilogram. So mass of the electron we found that 9.109 into 10 to the power of minus 31 kilograms. Now we can get the charge of the electron. So the charge of the electron, mass is the substitute values. If you multiply with these, you will get the charge of the electron is 1.602 into 10 to the power of minus 19 coulombs. What is that? 1.602 into 10 to the power of minus 19 coulombs. This is a charge of the electron. So now come to the anodes. So what are the anodes? The charge of the electron minus 1.602 to the power minus 19 coulomb. Why? Because charge that we consider there is a E is a electron is negative charge. That's why we are taking here negative side. That's it. Okay. So in the next we will see the anodes.